Even I am feeling that the net issues are there. So before going to the concept to calculate the concentration of the components, so let us go with the separation technique, and in the next coming session we can discuss about the concentration of the solutions. Understood? Yeah, one more concept is left in between, like a concept, how to calculate the concentration or percentage of the solution, solute present in the solvent or solution. That we are going to discuss in the next coming session. Before that, let us go with the separating the components of a mixture. Yeah, right? Yes? So here, separating the components of a mixture. So why to separate the components present in the mixture? So there are 3 different reasons to separate. Okay. So whenever simple reason can I give without knowing or unknowingly, you'll do this. Okay, for example, if your mother has given you a healthy leafy vegetables and different salad along with the dry fruits or somewhat, it's a mix, it's a kind of salad. So in that, few things you don't like to eat. Like few raw things you don't like to eat. Then what you'll do, you'll separate it. Because you'll feel that those things are unwanted and you won't like it. You'll do that? You'll do it or not? Yeah?
No, ma'am.
No? That means Arnav is a very good. Very good. He's very good. Arnav?
Yes,
very
ma'am.
good. Very good. That means whatever your mother will give, you'll eat. You won't pick anything.
No, ma'am.
That means very good. It's like it's very good. Nice to hear that. Sounds good. What about Sahas? Yes, you don't have any. You can text it, dear. Sahas, Milan. What some children will do? Your mother will give all a very good healthy diet, and in between you just selected the unwanted things from that. Which your mother don't likes that. Am I right? Even I'll face it. As a mother, I'm facing it. That's why I have given that example. So, Arna, very good. Very good. It's very good. It sounds good. Okay, so like Bhumika, you? What about you, Bhumika? You'll eat everything? Like veg, green? Yeah? Yeah? You're saying something, dear?
Ma'am, I eat everything. Ma'am, it's not like, ma'am, it's not specified that I want to eat this. Ma'am, I eat everything.
Very good, very good, very good children. I really love it, hearing that. That means you are very good and you are very understanding. Am I right? Very good. Keep it up. God bless you. Okay. So in that sense, like some children, rarely, okay, not you people, some other children. I just give the example. What they'll do whenever they get, they just be using hand picking. Different separation techniques you have learned in the like earlier classes, like crushing, winnowing, hand picking, sieving, all this. We'll do different separation technique. It depends upon the property, or it depends upon the components present in the mixture. Do we select the same separation technique for all the kinds of mixture? Some will do filtration technique. For example, if the rice containing pebbles or stones, what we'll do? We'll do hand picking to remove it. Yes or no? To filter the tea leaves from the tea, we'll do filtration. To go with the separation of salt from the sea, crystal salt from the sea, we'll go for evaporation. Is that the separation technique is common for all the kinds of mixtures? No, it's not possible. It depends upon the components present inside the mixture. Understood? Any doubts? So reasons for separating the components of a mixture: to get a pure sample of a substance. 1. To get a pure sample of a substance. 1. That means We'll separate the unwanted. We separate the, we want the pure ones from the mixture, then we go with the separation technique. That is the one reason. Especially when you do the research work in the laboratory, we require the pure reagents, not the impure ones. Then only we'll get an exact product. When your mother wants to prepare ghee, definitely she requires a pure milk. Pure in the sense without any impurity, without any adulterations or anything. She wants the pure milk. Then only she can do it. In that consideration, we'll do the separating, separation. We will select the separation technique to go with that. Second one, to remove any undesirable or harmful components present in it. Definitely, the rice containing grain, pebbles, we can't cook directly the pebbles because they are not good for our health. We can't digest the pebbles. So definitely we use by using hand, we definitely separate it. Understood or not? Yes or no? In that consideration, to remove any undesirable or harmful components present in the mixture, we'll go with the separation technique. One more reason. To obtain the useful mixture components of a mixture, for example, the crude oil, petroleum or a crude oil. If I take a petroleum or a crude oil from the crust of the ocean, so what I'll do, I just take it, but the components present in the crude oil all are useful. The coal tar is useful, natural gas is useful, petrol is useful, kerosene is useful, diesel is useful, naphtha is useful. Am I right? So all these are the components present in the crude oil. All of them are very useful. So that in consideration, to get all the components which are very much useful to us, so that I'll go with the separation technique. Separation technique to get the components present in it. Understood? So keeping in mind these all three reasons, we select the separation technique. One thing to get the pure samples, the other one to remove the harmful or the unwanted things, and the third one to, if the mixture consists of all the components are very much useful to us, definitely we'll go for the separation technique. So actually why these separation techniques are used? Because they are heterogeneous in nature. The components present in the mixture are heterogeneous in nature. They are showing different properties. They are not completely mixed up with the components present in it. They don't have any fixed proportions. That's why we go with the separating the components of a mixture. Any doubts? Any doubts? Arnav, Bhumika?
No doubts, ma'am.
Next one. So these are the different separation techniques. One is evaporation, centrifugation, separating funnel, sublimation, chromatography, simple distillation, fractional distillation, crystallization. So all these are the different separation techniques. We are using it in our coming sessions, and even in these sessions we are going to complete pure separation technique. And we elaborately, in brief, we are going to discuss by using different applications or different examples. Okay, first one, evaporation. So I'm going to show you the videos. Let me explain each. First one, evaporation. The first one, evaporation. Simply, where we find this evaporation children in general. So in water cycle, especially in water cycle, we find like evaporation from the sea. Understood? Evaporation. So after evaporation, there is a formation of clouds. From the clouds again, in the form of rains, this is known as condensation. This is a simple cycle. In general, we'll observe that evaporation process takes place. And one more evaporation, as you have learned in your early classes about evaporation, by using like a separation of crystal salts from the sea. That means they collect the seawater and they have dropped the seawater in different shallow blocks in an open area, so that the water gets evaporated for after few days, so that the leftover will be the crystal salt. This crystal salt has been taken to the industry and it is undergoing like different refining process. When it is undergoing different refining process, so they are going to remove the other impurities. Not only the sodium chloride, which is required to us, many other unwanted salts and harmful salts are present along with the seawater. Then they'll go, after evaporation, they'll go with the refining process in order to get the pure salt, pure crystalline salt, or even the table salt. So that is one more example. But according to your this thing, evaporation means evaporation of solvent from the blue ink. Evaporation of the solvent from the blue ink. Simply. So take ink, especially blue ink. When you have taken the blue ink, place the blue ink in a container. For example, it's a China dish. Add the ink in it, blue ink, and allow it for heating. So this is a tripod stand on which you just place the, what we can say, the China dish containing blue ink. And this is wire gauze. Wire gauze is used to give the uniform supply of heat to the entire, what we can say, that the China dish. And this is Bunsen burner, which the burner or spinner. So what happened? Directly will heat. It will heat directly. So it will undergo charring. So that in a low flame only we need to heat it, not directly giving the burner. For example, it's the bestly convenient by using the candle flame, because the candle flame is not much effective in giving the hot heat. So in that sense, we'll take the candle flame and evaporate it. So after some time, we'll see that water or the solvent, which is present inside the ink, in order to make the ink in the liquid state, so it completely evaporates. So after cooling, we can find that blue dye is present in it. Blue dye is present in it. So it's nothing but a blue dye present in it. Any doubts?
So ma'am, we have to heat it slowly.
Yes. Not slowly. Low heat will be given. Because if you have given directly, what happens? It gets charred. Charred in the sense? Burned.
I don't know. Okay.
Burned completely. If you leave the milk, like if you allow the milk to boil, after some, when the milk at its boiling point, immediately we'll off the milk. So if we keep on heating the milk, what happens? It will undergo into condensed state. So even though if you are heating continuously by giving high flame, what you will observe? You will observe the charring of the milk. Like dark brown color, it's nothing but a charring of milk takes place. Understood?
Yes, ma'am.
So that's why the precaution what we need to take it is, otherwise take a beaker containing water. Place the watch glass. You know the watch glass, no? Place the watch glass. You don't know? Don't know? Yes or no? Watch glass, you know? It's like a small glass plate which we'll use in the laboratory to take the samples. Place the ink in the watch glass so that what happens, you just take. If it is a beaker, above the beaker, just place the watch glass containing blue ink. So that with that steam only, it starts evaporating. So the direct flame cannot be given like that. Okay. So in that sense, complete solvent will be evaporated. What will be the leftover? Blue dye. After cooling, just scrap out the blue dye. Understood?
Yes, ma'am.
So evaporation is used to separate blue dye from blue ink. But there is a technique to go with it. But in general, we can do at our home also, but don't do any activities or any experiment at home. Only in presence of your teacher in the laboratory only, teacher will tell you how to hold the apparatus, then only you can do it. But at home, no practicals can be entertained because they are very harmful. You don't know what is the boiling point. If there is any chance, it will get spills off. So again, it is a very dangerous thing. So I'll show you the video, a small video for evaporating the ink. So how to scrap it in general. But especially when we go with the laboratory technique, we take the beaker containing water. We allow the beaker to heat directly, containing water. So above that beaker, we just place the watch glass or the glass plate containing this blue ink. So with that steam only evaporation will go, not the direct heating. That is a best process. And it's a best laboratory technique to go with the evaporation process. If we heat directly also, we can do that. But if we give the direct heat, it will undergo for charring. It's like if we need a slow process to observe the reaction, or simply we can say that how the evaporation takes place. Understood? So I just want to show you.
Ma'am, screen is not visible, ma'am. It is coming blank. Nothing is visible. Ma'am, you are muted.
For me, it's clear. This is happening with everyone? Arna, Milan, Sahas?
No, ma'am, it's visible.
It's visible? Yes, Arna, no need to send any link here.
Ma'am, this is the link of this video.
Yeah, no need to send that. I'm showing it now. So evaporation, what are the in general things evaporation is observed in the obtaining of crystal salt from the sea? One example. The other one we can give like, so like crystal salt from the sea, and one more we can give like this blue dye, and even the water cycle we can say that evaporation takes place. Okay. So all these are the or one more thing we can go with evaporation. If the solution is heterogeneous, like sand is simply we can say that if the salt is required, not only sodium chloride, any other salt. So water is having the ability to evaporate. So when it is evaporated, so we'll get the salt back. Okay, in both in industrial technique and even that natural process also we can go with that. Okay.